All right. Can everyone hear me? So welcome everyone. In this session, we'd like to go over how we at Office 365 are using Spark Analytics to power some of our scenarios. So here's what I'd like to go over. We'd start with some basic introductions, won't spend too much time there, but we'll dig into Delve Analytics, go over our architectural setup, we'll talk about our Spark environment, and hopefully leave you with some use cases and best practices that we've figured out over time that will hopefully help you guys. So who are we? My name is Pavani Jayanti. I'm a senior program manager at the Office 365 organization at Microsoft. More specifically, I work on the Customer Fabric platform team. Wendy here is also a senior developer on the same platform team. The charter of our team is specifically to help attract, engage, and retain our users with the help of our big data applications. So let me begin by setting the stage for Office 365. As some of you already know, Office 365 refers to subscription plans that allow you access to Word, Excel, PowerPoint, and other large cloud-based services such as Exchange Online, you can get Skype for Business, OneDrive, and more recently, Delve Analytics. So I'll jump into Delve Analytics in just a second. So Office 365 is a massive, massive service. We have tens of millions of users all across the world. We have data centers strewn across the world to serve these users. We have an ever-increasing install base. We also allow productivity on the go, which means you can use your mobile phones, your tablets, etc., to use these Office applications. What that's resulted in is an excess of 30 million iOS and Android devices running Outlook. We have 1.6 billion sessions a month connecting from phones and tablets alone. The whole point of all of this was to give you a sense of the scale for of Office 365, and more importantly, give you a sense for the amounts of data that we're actually consuming that we can run our applications on. So let's dig into Delve Analytics. So how many of you feel overwhelmed by your email? Do you actually just want to shut your laptop and stow it away because you never get to the bottom of your email? Thanks, Wendy. I guess we suffer from it. And also, how many of you feel guilty as parents when you have to log in after work from home, with your 2-year-old around? So if you fit into any of these categories, you should check out Delve Analytics. Delve Analytics is a recent offering of Office 365. Its sole purpose is to empower you and me to actually make better use of our time. So what Delve Analytics tries to answer two basic questions. How do you spend your time, and with whom do you spend your time? So some of the questions it helps you answer is, boy, how many hours do you spend in meetings? How long do you spend in writing email versus reading email? How do you compare with the rest of your organization? And I'll get into some specifics in just a second. But Delve Analytics is currently offered in the E5 SKU in Office 365. You can also add it on in the E1 and E3 subscriptions. I do also want to point out that Delve Analytics by default inherits all of the Office 365 compliance, privacy, and security considerations. So all these cool insights that you see are for your eyes only. I do not have access to your data. So this is what a Delve Analytics dashboard looks like. So what you see here is a bunch of insights served up to you. On the top, you see a bunch of insights regarding how you spend your time in meetings, in email, in focus hours, and after hours. What you can do here is set goals against each of these and see how you're tracking towards your goals across the entire week. All of us are different. Each of us have quirky work patterns, so you can actually configure what you define as your office work hours, so to truly customize this experience for you. Aside from that, there's some inherent built-in smarts. So actually, what is a meeting hour? What actually qualifies as time that accrues toward a meeting? And we define a meeting hour as something that you book on your calendar with at least one other participant. So it has to be a collaborative effort. So if you just block out an hour and you're by yourself, we don't really count that as a meeting hour. Aside from that, if, say, you've been invited to a meeting and you tentatively accept it, we don't actually count it towards a meeting hour. You have to accept a meeting for it to count towards a meeting hour. So there are some inherent smarts to truly make this as accurate as possible to reflect reality. Other than this, on the lower half of the dashboard, you see some collaborative info, who are your most active collaborators, how much time you're spending with them, whom you're losing in touch with. At the bottom, you see some statistics for those of you who care about how much time you're spending with your manager, how long you take to respond to their email, how long they take to respond to your email. It should give you some sense of what you're interacting. The goal, obviously, is to keep everyone happy. And we feel that's the only way to truly attract, engage, and delight our customers. So how do we go about doing this? We do this right now with the help of a common analytics platform that's powered by Spark and a shared insights repository. So the goal here is for everyone within Office 365 and the company to actually do quick multi-signal analysis on these various different streams that are flowing in to discover insights and then operationalize these insights. Once these insights are created, we can then serve them up via APIs to power our end-to-end scenarios. All of this to truly, really understand our customers and build experiences that delight them. So I've walked over, the scale of Office 365. We had some basic requirements. Obviously, we wanted running in the cloud. We needed highly scalable. We wanted extremely high ingestion rates. We wanted to be able to do some real-time analytics, some batch analytics. We wanted some machine learning capabilities. And this is sort of what we came up with. On the left-hand side, you see a bunch of our data sources. So these range right from Office 365 servers, emitting a bunch of service information. We see below that a bunch of client and apps, so your phones, etc., emitting metadata that we consume. We have a bunch of commerce systems that deal with billing, subscriptions, what have you. We have support systems, who's called, how long did the support call take, how many tickets were resolved in a day, etc. And many more such streams. Kafka right now, so we picture Kafka as a data highway, just a bunch of streams flowing in through Kafka. Once the data is in Kafka, we use Spark streaming and Spark batch processing to create these insights, and we'll get into the specifics a little later on. Our store of choice right now is Cassandra. We serve up our insights via REST APIs. What you saw on the Delve dashboard is being powered up by Spark Analytics. We also have your tenant admin portal, if any of you are familiar with it, is powered up by Spark Analytics. We have a bunch of support tools that we use built off of it. Aside from that, we do some ad hoc querying with Zeppelin. We also have hooked up Splunk to Kafka for some log analysis. We create ad hoc reports in this way. So right now, I'll walk you through two basic use cases. Spark streaming is playing a more and more vital role in our analytics story. So as an example of where we use Spark batch is in the support space. Here we actually we know your subscription's about to expire. Can we help you renew your subscription? This in the past has given us rave reviews. Like, we've gotten very positive feedback for doing this from all these customers. One other thing I'd like to point out is, aside from actually just the support ticket, we also give our support agent sort of a holistic picture of our customer. Like how many issues they've seen recently, what we know about them, so that when the support agent actually reaches out to the customer, he can really empathize with the customer because he has that understanding beforehand. So the next use case I'd like to point out is how we use Spark streaming. We use this in the service world. Many of you already know the reality of a service is we have incidents, things go down. The key is to sort of detect these incidents proactively and preemptively and act in a timely manner. And so right now we do this with the help of Spark streaming. So we have a bunch of error information that flows in, and when we begin to see a spike in errors above a certain threshold, we wake up an engineer and have them go actively fix the issue before it escalates and impact more users. Aside from that, we use Spark streaming to also narrowcast the communications to specific users. And we can do this by actually correlating the errors with our topology information, so we know which exact specific set of users have been impacted, and then we actually communicate to them, right from when the incident happened to ongoing updates to when it ends. That's it for me right now. I'd like to hand the stage over to Wendy, who will walk you through some specifics about our Spark environment and talk you through some of our use cases and best practices. Thanks.
Thanks, Pavni, for give us a great introduction of the system and scenarios. I'm Wendy. I will talk about the technical learning that we have. So let's start with the environment. We are using DataStax's official and enterprise version 4.8, which bounded with Spark 1.4.1 and Cassandra 2.1. All our nodes are running on Azure. We have multiple clusters that powers different scenarios. You may ask, why don't you put all your scenarios into one giant cluster? There are two reasons. First, we want to isolate the different scenarios to different environment. So if one scenario has problem, it won't impact others. Second, we are using different usage pattern for different scenarios. So we can tune the cluster based on the scenario to get better performance. For each cluster, we have 3 different data centers. Cassandra data center has a streaming job that's running on it. This is the only DC that has ingestion coming in. Analytics DC will have the batch job running. And exploration DC, it will have a zip line running. People can run ad hoc query on it. We established a separate exploration DC so that an accidental bad query in the exploration DC will not impact the Cassandra and analytics DC, which are responsible for the ingestion and the job execution. For the Cassandra and the analytics DC, we have the replication factor of 5, and for the exploration DC, we have the replication factor of 3. So that since we are using the local quorum for all our reads and writes, so we can afford 3 nodes down in our Cassandra and analytics DC, and 1 node down in our exploration DC without impact the functionality. So the ratio of the Cassandra, analytics, and exploration DC, it depends on the usage pattern for each different scenario. But normally, we will keep a ratio of 2 vs 2 vs 1. All the DCs for the cluster are in one virtual network. Each node was assigned an internal static IP. There are no inbound access to the nodes from outside of the VNet is allowed. At the beginning, we used the Azure G4 machine as our Cassandra nodes. Recently, we changed to the Azure D14 machine. The difference between those 2 VMs are the memory. The G4 machine has 224 gig memory, while the D14 machine has 112 gig memory. Although for single nodes, G4 has better performance on the throughput and the latency. But since the Cassandra scales better with smaller machine and more nodes, at the same cost, we can have double nodes count in our D14 cluster. So we get better overall performance with our D14 cluster. Let's see. Okay, page down. Okay, so all our scenarios are fall into 3 different usage patterns: near real-time processing, batch processing, and ad hoc querying. The first usage pattern I'd like to talk about is near real-time processing. After taking the data from the Kafka, the Spark streaming job will do all the aggregations. So it pipes data from one stage to another. For example, we have a Kafka ingress processor, which will take the data from Kafka and do some normalization. Then we have an aggregator, which will do all kinds of aggregation in a small time window, like 5 minutes. And then the Cassandra writer will write the result to Cassandra. We use this usage pattern in multiple scenarios. One example is the service scenario that Pavni introduced before. Detect the impact of a service incident. in real time and narrowcast the status to the users. This user pattern works very well if the scenario does not have a big look-back window. Also, it works well if the data stream has some degrees of tolerance of the event disorder or late or missed event. The pros of this usage pattern is very obvious. It's near real time and has less than 5 minutes latency. And it will store less data in Cassandra. The cons is if the cluster is unhealthy, since the buffering window is small, it is not easy to recover the data since we don't have the raw data stored. So we're also looking to replay the data and event from Kafka, try to help with these cons. For the cluster that heavily use this usage pattern, we will put more nodes in our Cassandra cluster, Cassandra DC. Usage pattern number 2, batch process. In this usage pattern, we use the Spark streaming to bring in the raw data and use the scheduled Spark batch job to do further aggregation and analysis. This usage pattern works very well for the scenario that the event accuracy and ordering is very important. Don't necessarily require near real time. A few hours delay is acceptable. One example is the support signal. Each support ticket will have the status of new, active, resolve, and close. The order of the ticket is very important and cannot be mixed up. There are also some scenarios that need to do some trend study. For example, if you want to do analysis on the mobile trend, mobile usage pattern over the time, in such case, you will need to look back a few days, weeks, even months data. Although we will need to we probably need to join with some common data set like user or tenant metadata. We can have the batch job run against Cassandra to generate some trends or insights that we are looking for. The pros of this usage pattern is the high data accuracy. Even if there are some outage, after all the raw data arrive in Cassandra, we can backfill the data by rerun the batch jobs. Second is the complicated analysis, like top-end 90% tail of latency for large time window becomes feasible. We can also generate some common data set that can be used by other jobs. For the cluster that heavily use this usage pattern, we will put more nodes in the analytics DC. So there are many reasons why you will need to have ad hoc query against your insight store. Sometimes project manager needs to look into the data to explore what kind of insights is more valuable, so they can design their scenario. Developer might also need to access the data, try to find out the data shape before they start design their Spark job. Or they may want to validate the data to ensure the job accuracy. In addition, you never know if a CEO like Satya will ask you to get some insights from the insight store. Here, we use zipline interpreter, which support the Scala or Python with Apache Spark SQL, to run ad hoc query to understand the data better. This usage pattern opens a door for us to get easier access to Cassandra. Non-technical person can use SQL-like query to access the data without build the Spark job and the REST API. The pros of this usage pattern is flexible. And although we have 3 different usage patterns, most of the time we will use more than one usage pattern for a scenario. Now I'd like to share some kind of perf tuning experience that we have discovered along the way. Let's first talk about the streaming job. One issue we have seen in a few clusters that I'd like to share is about the streaming job performance. We have a streaming job with a batch interval of 5 seconds. However, we notice in the batch, the events in the batch, it took more than 3 seconds to process, sometimes even more than 5 seconds. It caused the scheduled job delay, becomes too long, and it gets worse over the time. During the investigation, we find out the driver constantly reestablish and rediscover the cluster. This is because the connection has a keep alive default value of 5 seconds. So when the next task start execute, the connection already closed. So by increase the keep alive millisecond to 30 seconds, the process average time went down from 3 seconds to 800 milliseconds. For some of our streaming job, we have the job record the number of events it pulled from Kafka and the number of records it saved to Cassandra. While this operation gives us some optics to understand how our job is doing, it also brings some overhead to the job. When we started that work, we were using receive-based approach. For a job that has batch interval of 1 minute, it takes around 16 seconds to process the events, even if the number of events is not so big. During the investigation, we found that if we cache that batch, we can reduce the time to process to 4 seconds, because it helped avoid recomputation of the RDD every time it is used. This is a good learning because normally we will only cache it in our batch job, but not aware that we can also use it in the streaming job. So there is also one time when we saw some Spark streaming job running very slow. By digging into the code, we found some of our code has insert and update while which is a synchronized operation. By change to the asynchronized operation, like save to Cassandra, the performance improved like 10x. So we also have some learning in the batch jobs. So there is a few. To summarize our finding, here is 5 bullet points. You can take a look. So I'd like to end with a video on the dev analytics. Let me see. Somehow.
And we're going to open up the.
Yeah, there you go. Okay.
We're going to open up the floor here to questions here pretty soon.
In this data-driven world, time is of the essence, not only to us as individuals, but also to the bottom line. But how can we make better decisions about how we spend our time? Meet Delve Analytics. Delve Analytics empowers individuals through rich dashboards that provide insights on time and relationships. Use your personal dashboard to monitor your time, and then take action. For example, see what percentage of your emails get read, track who you collaborated with the most, or who you were losing touch with. See how long you are spending in meetings, and reprioritize your goals. The metrics are tracked against goals you set for yourself. You also receive these valuable insights in a weekly report delivered in Outlook. Delve Analytics is a powerful new addition to Office 365, helping you get your time back and leveraging the intelligent cloud.
All right, we've got a few minutes. I'm going to open up the floor for questions here. If you have a question, please raise your hand and I'll come see you and give you the microphone. So who's first? Here we go.
Thanks for the interesting talk. My question is, how much is the period of data stored in Cassandra? Like how many months or how many years?
So it depends. For the raw data, we normally will store the, let's say, 1 day kind of. Then for the aggregated data, we will store the months and even years.
Can you talk about why you choose Cassandra as your data store?
That's a good question. Actually, we did some exploration. The first version we have is we use an in-memory store, which is called.
We actually, we evaluated a bunch of technologies. Our big thing was we wanted a columnar store, we wanted high scale. And so we had, it automatically narrowed it down to a couple of choices. We have some technologies in Microsoft that we could have used. There is Cassandra, we looked at Redshift, we looked at Mongo, we looked at a bunch of technologies. We did some prototyping against each of these, and we picked Cassandra just purely for a columnar store with giant scale. We're talking petabytes of data from users, customers, tenants across signals. So we wanted something that will potentially scale linearly. So it's a matter of throwing nodes at it and scaling the clusters. Yeah, that was our initial thinking on why we chose Cassandra. Aside from that, all of the way our code works is it's reasonably decoupled. So we should be able to use potentially multiple storages for different use cases. But right now, our insights are stored in Cassandra.
Are there any other questions? Oh, one over here. I think you're going to be our last one.
Along the same theme, do your operational processes, for example, the workflow process where your customer service agent is making the outbound call to the client whose account is expiring, are they reaching into Cassandra, or then do you have another job that writes that on into some sort of operational environment?
So right now what happens is we run these. Hi. So right now we run these jobs periodically. So right now it's scheduled, we can run it every 6 hours every day. So let's say we run a job that flags customers as of today, who's who very active in the past and whose subscription's about to expire. Once we run them, we automatically create that ticket. Then from there on, it's actually a manual process where the support agent actually picks up the call. I'm not sure if that actually answers your question. It's a REST API that we actually, it's a REST API that we expose it to the support agent in terms of a dashboard. But yeah, otherwise it's an automated workflow that we've created every time an insight, yeah.
All right, that's all the time we have. Thank you very much. Let's give these guys a round of applause.
Thank you.